Algebra 1, Lesson 10.3, Operations with Radical Expressions. All right. Sorry, I want black. I forget to check that beforehand sometimes. 10.3, Operations with Radical Expressions. I think overall you're going to like this a lot better than Lesson 2. It includes a little bit of Lesson 2 kind of stuff in it, but for the most part, it's its own separate thing and quite a bit easier. Uh, what if we had something like this? What if we had, I want blue. What if we had something like 2x plus 3y? Can that be simplified? And the answer is no, because x is its own thing and y is its own thing. And we don't know if x and y are the same thing. So if we have two x's and if we have three y's, because we don't know what x and y is, or at least theoretically they're different from each other, then we cannot combine them. And it works the same way with square roots. So if we had something like 2 square root of 5 plus 3 square root of 7, we can view it as we have 2 root 5s and we have 3 root 7s. Can these combine? And the answer is no, because root 5 and root 7 are not the same thing, so we can't, we can't say like, oh, if you have 2 root 5s and 3 root 7s, then you have 5 root, well, they're different from each other, all right? But if the different terms match each other in what you're taking the root of, then you can combine them. So if we had something like 2 root 5 plus 8 root 5, well, now we have 2 root 5s, and we're adding another 8 root 5s. So how many root 5s do we have total? We have a total of 10 root 5s. So that's the gist of what's going on with this lesson. Where it ties into the previous lesson a little bit is sometimes there will be a little bit of simplifying that we need to do because what's inside the radical can be simplified. Okay, but I just have 5 sample problems for us to do that I think will give you a good sense of what to do with this, and that'll be it for this lesson. Okay, so first example, simplify 8 root 7. That's an 8. 8 root 7 plus 3 root 7. And you can just view it as, well, we had 8 root 7s. We're adding 3 more root 7s. How many root 7s do we have total? We have a total of 11 root 7s. That would be your answer. Next sample problem. We have, again, simplify. Really, all these are simplify, so maybe I don't need to keep writing simplify each time, but that's what's going on. Simplify, let's do 4 root 2 minus root 18. All right, now at face value, there's nothing that we can do here because the first term is based on root 2, and the second term is based on root 18, and those don't combine. But root 18 can be simplified. So what we're dealing with here is 4 root 2 minus, and root 18 is the same thing as root 9 times 2, right? Okay. So then we have 4 root 2 minus, what's the square root of 9? But 3. So minus 3 root 2. Now they match each other. We have 4 root 2's and we're taking away 3 root 2's. How many root 2's are we left? We're left with just 1 root 2, which we would just write as root 2. So that would be your answer there. Okay, next one. Simplify. 2 root 3 times 4 root 3 minus root 2. All right, here we have distribution. So if we distribute, what do we have first? We have 2 root 3 times 4 root 3. That's, this one times that one. And then we have this minus 2 root 3 times root 2. That's this times that. All right. Now we can take these one at a time. I like to do the numbers first. So we have 2 times 4. Sorry, they're all numbers. The numbers outside the radical. I like to do those first. So 4 times 2, that's 8. Root 3 times root 3, well, that's 3. So we have 8 times 3 going on here. And we have minus 2. And root 3 times root 2 is root 6. And there's no perfect square inside of there that can be simplified. So 8 times 3 is 24. So we have 24 minus 2 root 6. That's as far as we can go. As we checked this root 6 to see if anything could simplify there, and nothing can. And the number 24 cannot combine with something that's based on root 6, because like we have 24 root 1s, you could kind of view it as, because the square root of 1 is 1. 24 root 1s minus 2 root 6s, and they don't play together. They don't combine. That's as far as we can go. All right, next one. Here we have simplify. Root 20 plus root 50. And this is another at face value. It doesn't seem like they can simplify, but at least it doesn't seem like they can combine. But we need to check each individual radical and see if it can simplify. Well. 20, we could say is 2 root 10, but I'm sorry, 20 we could say is the same thing as 2 times 10. But 2 times 10, 2 isn't a square, a perfect square. 10 is not a perfect square. But what if we represented the 20 as, so square root of 20 as a square root of 4 times 5? Okay. And then how about we have plus the square root of, well, 50 we could say is 2 times 25, right? 2 times 25. And let's see what can happen here. Well, I know here that the square root of 4 is 2. So I can say the same thing as 2 square root of 5. And then here I can say the square root of 25 is 5. So this leaves me with 5 plus 5. And that 2 is left inside. So you have 2 root 5 plus 5 root 2. And that's as far as we can go, because root 5s and root 2s don't play together. Okay. If we had ended up with, well, let's do one where this could go one step further. So let's say we have, let's say we go simplify I can stick with the root 20 plus let's see. Hold on a second, sorry. Root 45. There we go. Okay, same thing. Well, I can say root 20, that's the same thing as root 4 times 5. Plus, well, root 45, that's the same thing as root 9 times 5. Okay, so then the square root of 4 becomes 2, so I'm left with 2 root 5 plus square root of 9, that's 3. So I have 3 root 5. Now they combine 2 root 5s plus another 3 root 5. I get 5 root 5s. So that would be that answer. All right, one more example. Sometimes we need to FOIL, multiply two binomials by each other. So that would look like simplify. Let's see what we get. I have a root 5 plus 2 root 7 times 3 root 5 minus root 7. And let's see what happens. So I'm going to take this root 5 and multiply it by that, and then multiply it by that, and then take this 2 root 7, multiply it by that, and then multiply it by that. So when I do the root 5 times 3 root 5, so that's root 5 times 3 root 5. All right, and then I have minus root 5 times root 7. Then we have, so I use the root 5 twice. Now I'm going to use the 2 root 7 twice. So plus 2 root 7 times 3 root 5. Okay. And then I have minus 2 root 7 times root 7. Hope they're able to track with that okay. Now we just need to simplify each of these chunks and then look to see if anything can combine. So 3, all right, and I have root 5 times root 5. Root 5 times root 5 is 5. So this becomes the same thing as 3 times 5, so that's 15. Minus root 35, 7 times 5. There's no perfect score. Well, 5 is prime, 7 is prime. When you multiply two prime numbers, you get something that does not have a perfect square in it. All right, so now what do we get here? Plus, well, 2 times 3. Right, if I use those, 2 times 3 is 6. So I'm at 6 root 35. And we have minus 2 times root 7 times root 7. Root 7 times root 7 is 7. So 2 times 7 is 14. Okay, well, let's see. The 15 minus 14 simplify, or combine. That's 1. And then I have a negative root 35, or a negative 1 root 35, and then a positive 6 root 35. So this becomes plus 5 root 35. And that is as far as we can go. All right. That's lesson 3. It's the kind of lesson where it's just like, I think just seeing examples is the main thing because there aren't necessarily like lists of rules or steps to follow and stuff like that. It's just getting a feel for what's going on and how to do it. So hope it goes well. Give me a holler if you have questions. Bye.